So Jessica, if you use the BU command, should work. Instead of BP. You have to do 0x in front of the address. Yeah, it's kind of goofy because in all other situations, Windybug, assumes everything is hexadecimal, but in its assembly mode, you have to prefix with 0x. How you guys doing over here?
Okay, I can't get the jump to work. On this to Y.
You mean it's like not actually taking the jump, or the jump isn't going to the right place?
Jump doesn't seem to go to the right place.
So if you do a DB on that address 12FD80 should be your shell code, right? So yeah, it looks like a shell code. Okay, and have you put those bytes into your payload? Okay. This should be alright. So you're doing the bytes backwards, and for those you don't do them backwards. These are just x86 opcodes. It's only 32-bit addresses that you do backwards. There you go. There you go. How's it going, PowerPoint Ninja?
I was just trying to get that, calculate the jump.
Yep. Using the A command.
Well, just trying to, I keep missing it up here and there.
Oh, some help? You want to keep fighting at it on your
I think I get 5 out there and another 3 minutes.
Okay, cool. So over again. Okay, let's see. Calculate it from? Yes, it does, because it's relative jump. So you have to calculate it when you're on that CC byte, right after the pop return. So CC and C3. C3 is return, CC is software breakpoint.
Yeah, so I think this is, so I had done
There's no choices.
one was I think it was a lot.
There's no choices.
Okay.
I'm gonna try to go back.
Okay.
Rank up there. So,
Do A. Shell. If that's your shell code. I'll do a DB on that. Actually, press enter one more time. So it actually assembles. I'll do DB on that address to make sure your shell code's actually there. DB on 12FT50. Oh, you're pressing.
get debriefed
So yeah, that's right. Okay, so just take those bytes associated with the jump and hack them where your CC bytes are. So you actually want to put in the bytes for the jump, like E9, 3, 8. So you're putting the address in there. You want to put the bytes that actually tells the processor to do the jump, which is E9, 9, 3, and you can see that in the WYSIWYG outputs. So those are the actual x86 opcodes that we jump. We need another add that in there too. Yeah. So you were just putting the address there, and you had to actually tell the processor, because at that point, the processor is pointed at those opcodes, and you need to tell it, okay, processor, I'm giving you the x86 opcodes and jump backwards to my shell code. It's going over here, Dave.
I've done the same thing.
Yeah. See what happens when you NG. So it looks like you overwrote the exception handler function pointer with CCCC. So So you need to overwrite that with pop return. Yeah. Yeah, because you got to remember the debugger is just telling you, okay, an exceptional condition just happened. Do you want me to like do something about this, or let the process try to handle it?
Oh.
Yep. Yeah. Oh no. Your pop return address isn't right apparently. Six two E49 E. Yeah, you gotta do F7. Looks like. Yeah, the rest looks right. Oh. Oh, it's because it did the pop return, but now it's executing whatever is after your pop return. So there's probably, if you open up HXD, you should see an A byte right after that address of the pop return. Oh yeah, it's because you put the A's right before. Because remember, it's going to set the the EIP right before that pop return address first. So you have to do the EB06 right there. So if you change that to EB06, then it should jump to the CC buttons.
DC.
Yeah, there you go. I know, mental endurance is wearing thin. We're almost home free though. Now you assemble and jump backwards too. All right, so Sam and Christina and Jessica, how's it going on your end?
Sam is talking with Gino to do something. Anyway, so we are doing lab here together. So Gino is working with Sam.
Okay. You did? Yep. All right. PowerPoint Ninja?
The jump's not quite good yet, but calculation.
Yeah, Sam, I think GS protection is turned on this thing, so that ain't gonna work too good for you. Because remember, GS protection is going to check the value of that canary placed right before the return address, right before it actually uses the return. But with the exception handler stuff, we gain control of EIP before that canary's integrity is ever checked. So just trying to overwrite the saved return address would be no bueno.
I'm trying to calculate the jump.
Yeah.
Putting that in that, or putting it in backwards.
You don't have to put the bytes of the jump in backwards. The bytes of the jump go in forwards.
Oh, I think that's what it's.
Yeah. So it's just 32-bit addresses that have to be, switched to little Indian mode, but that's just telling you when the CPU is pointed at these bytes, that will tell it to execute a jump backwards. So you have to make those bytes appear in that order.
Alright, yeah, that was just my stupidity.
There's a lot of little things you got to get right with this exploit business, so it's easy to kind of like get one wrong and be like, what the hell's going on? So once everyone's gotten this, we're going to start looking at buzzing that old unpatched Windows XP virtual machine. So I'm going to give people like probably 10, 15 minutes more to work on this one. So we'll say, for those of you that are done that don't want to mess with the debt bypass one, you can take a break to like 1:45, and when we come back, we'll start looking at exploiting some old unpatched Windows vulnerabilities. Is there anyone on the BB cast that wants some advice that's having a hard time with this? $145. Then I'll start wrapping this up and moving on to the Windows XP bugs. going over there for decondering so deeply?
Just covering saving my files.
Yeah.
Should we go ahead and boot into the unpatched Windows?
If you want, yeah. Just don't go doing any of your online banking on it. I'm just kind of curious to see what will happen if you try to just browse for like Google in that browser, see what the proxy does. You'll get like an instant mint email from the manager. Huh?
Probably IE6, so it's probably not going to be.
Yeah, I had browsed even in this VM, and in this VM, proxy blocks you.
Did you try with Firefox too?
No, I didn't realize there's Firefox in here, but I know that they have rules on Firefox versions as well, so unless you put that on there right before you made it.
I mean, what you can do if you really want to browse is just like download Chrome and then drag and drop it onto the desktop and install it.
Probably not the best idea anyway.
Well, I mean, for this one isn't so bad. Patching is turned on these guys.
Use pull this steps for 5S for this. You don't have to actually go through it.
So the depth bypass, you would want to pivot the stack. Pivot the stack to attack the controlled data. You want to create a fake stack frame there. That calls virtual protect. And then the return address for your virtual protect stack frame should be the address of your shell code. How about VBcast people doing? Who hasn't gotten it yet? All right, well, I'll give you guys that are still trying to finish it up till, like I said, 1:45. Those of you that have already gotten can chillax for a minute, rest your brains, because the last part of the class will be exploiting that Windows animated cursor rendering vulnerability. So I think you guys will like that one. You want to be fresh with it.
What's the news looking like, Corey? I just saw, like, front page of Google News, 32,000 people evacuated as fire doubles in size. Do you have any, like, map that you are consulting that shows what the limits of it are?
Yeah, but it's not very up to date. It's just like from yesterday, and the fire is like changing rapidly, so it's not all that accurate. Some people did post some pictures. I'll show you guys. I mean, it's getting a lot worse. Apparently, last night it's basically reached hell on earth proportions. That's what Colorado Springs looks like right now. So, Centennial, I'm on here. My house is like up this way somewhere.
Nice
I
comment.
like the comment, yeah.
Pretty much sums it up.
I think that right there is the Air Force Academy football field.
Yeah, Air Force Academy was evacuated.
Yeah.
Never seen so much snow.
Let's see what the forecast looks like.
He's partly clouded. Mostly clouded.
I don't know,
Large chance of
Florida's
fire.
got some problems. Flood watch, really?
It's because all the vegetation has been burned. So if it rains, there's no, vegetation to hold the water in the ground.
So houses burn to the ground, flood out.
Yeah. Oh boy, that's a good forecast for a fire. Lightning, that's what we need. I think at this point it's kind of like, so I have like an apartment that I just moved out of and into a condo, and I still have little stuff there, and it's probably toasted and gone. It was like right on the perimeter last night. And then I have a condo that's in the southwest part of town, and the fire is really spreading northwest. So,
You said you still had stuff in your apartment?
just some little stuff, yeah. I mean, just like some crap that I had been.
And
too lazy
here's
to move
where
out.
giving your girlfriend the keys to your apartment might have been helpful, right?
And she's not there either.
Do you have the keys to her place?
She lives with me.
So technically, yes.
So, that was a couple. Just have some of the red. Yeah, there was like a pretty good one that showed like a satellite image, but it was actually like pretty old. So it apparently got really bad last night, and a bunch of homes just started burning, and basically the whole northwest part of the city is on fire. So I'm putting it like 50-50 whether or not my condo will survive. Luckily, there's like this highway, Highway 24, which bisects Colorado Springs going east to west, and they're saying that, we're trying to keep the fire from spreading south past Highway 24, because if it goes past the highway, it's like the whole city is going to burn down, basically. So if they hold that line, then my condo should be okay, and if they don't, the whole city is going to burn down anyway. So, but yeah, we'll see what happens. It's pretty bad. It's probably the worst fire they've ever had. All right, with that in mind, let's talk about exploits some more. Okay, so those of you that didn't get it, I document in the slides like pretty good how to go through the whole process. And once we're done with today, I can stick around a while longer and help you if you still want to keep working on that. but I do want to move on to like a real vulnerability just to show you guys that, you know, yeah, I constructed this Corey's crappy document reader, and you know, so I kind of made it so you might say that the bug was artificial since I kind of programmed it to have one. But I just want to show you that this method does in fact find like real vulnerabilities that have been out there. So as much as I want to show you guys like, you know, a real unpatched vulnerability or whatever, the management wouldn't like that so much. So instead, I went and found a really cool old Windows vulnerability, and it's got like an unpatched virtual machine. And then we're going to, you know, try to fuzz that out and develop an exploit for it. So what I want you guys to do is on your desktop, in the TSV folder, you'll see like the unpatched XP virtual machine. So go ahead and fire that thing up. Okay, so yeah, just a reminder, no one has any ethical problems with developing an exploit for like a real vulnerability, right? Speak now, forever hold your peace. Don't go talk to my manager saying Corey ordered me to hack the planet with this bug, this exploit. So everyone's cool with that, right? You guys are all cool with this? So this bug has been patched, obviously, but you know, I'm sure there's still computers out there running around that don't have the patch applied. So if you make your website contain this animated cursor that I give you, I'm sure you'll have lots of calculators popping up on poor grandma's computer when she goes to see what you're doing. Okay, so just an FYI, guys, this bug that we're going to deal with is very aggressive. Like, I mean, it's like the rendering of these animated icons, Windows is very aggressive to it. So if you like browse to a directory containing one of your exploit files or crash files, you're going to crash Windows. So try to do everything from the command line, because obviously the DOS console isn't going to try to render any graphics. So for instance, I'm sure everyone will accidentally do this at least once. Trying to change my properties here so the BBcast people can see it a little bit better. Hopefully that's a little bit better. Okay, so I'll only show you guys this once, all right? So this is what you should not do. I assume you guys still have it in here. So do not browse to this directory with Internet Explorer, because you can see I have this animated icon right here, which is kind of be our like original data that we're going to fuzz. And once you have, you know, crashes or exploits in here, as soon as you go to this directory with Internet Explorer, bam, you're hosed. So if I'm like, I didn't put this one. So yeah, I guess this one, damn, does happen. You'll have that happen. It'll just crash Internet Explorer. Now, what I did was, I didn't really know the details of this vulnerability. I was just looking for old, kind of cool-sounding Windows XP bugs. And all I read was animated cursors, you know, vulnerability in them, and bam. From that, I tried to recreate the bug, figure out what was going on, develop an exploit for it. And that's kind of a good way to, you know, get better at this exploit development vulnerability discovery thing. Is if you see a bug report from a vendor, they're obviously going to be pretty vague. It's going to be like, well, in this product, you know, under certain circumstances, this can happen. And if from that information you go and try to like fuzz out or reverse engineer what the bug is and develop an exploit for it, that's a good way to, you know, practice these kind of things. So that's exactly what I was trying to do. Okay, so in this directory, we have this animated cursor, which is going to be the original one that we're fuzzing. So that's like our known good. I have this HTML file, because the way we're going to set this up is we're going to create like a web page that causes the person browsing the web page to have your animated cursor. And if you look at the contents of that, you can see I just have a simple HTML file that forces this animated cursor upon to the poor person visiting your website with its ugly animated cursors. So the way we'll basically fuzz this is I've created this Python script, ANI fuzzer, which is almost identical to what I had you guys use for the CDF fuzzer. And what it's doing is it's pointing Internet Explorer at that HTML file. Okay, and that HTML file is hard-coded to load that fuzzy.ani file right here. And then with each iteration of the fuzzer, it's opening up the original one, mutating some bytes, and then okay, so you guys didn't. So I'll get you the password in a second, Wilbur. So it's opening up the original one, mutating some bytes, writing it to fuzzy.ani, and then it's pointing Internet Explorer iexplore.exe at this HTML file, the fuzzy.ani.html one. And fuzzy.ani.html is designed, like I said, to make the person display the fuzzy.ani, and then it's going to log to see if the Internet Explorer crashes when trying to visit that website. Okay? So what's important is once you start fuzzing, you will probably end up with some ANI files in your fuzzing directory, which will cause IE Explorer to crash. So if you browse to this directory, you're going to crash. So you need to launch everything from the command line. Like just typing HXD in the parameter to there and Notepad to look at the stuff. All right? Just because even if you do go to a text pad and do file open and browse to it in here, this little file explorer one, it'll still crash. Because it's still going to try to, you can see it's even now trying to bring these things. That's how kind of crazy aggressive it is about rendering all these little animated cursors. Okay? So the fuzzing method I used for this one, and this was just like my first stab at fuzzing out this bug when I read the original bug report, was instead of randomly flipping bytes, my sort of first approach is usually to sequentially write OXFF in the document. That way it's more deterministic. And I know that, OXFF, if there are any integer overflows in there, that's probably going to trigger them. So what this fuzzer does is it just writes OXFF in the 0th byte of the file, first byte, second byte, etc., until it's gone all the way through. So that's what the fuzzer's doing. That's going to generate some crashes. And so what I want you guys to do is to use the ANI fuzzer. And let's see, what's the directory there? It's in the C:/fuzzing directory. And I want you to use that to try to find some crashes and develop exploits for them. Now, before you get started, I want to say this. I've also included in the C:/fuzzing directory this heapspray.html file, okay? And what this one is similar to the fuzzy ANI.html file, except it's also including a heap spray. And basically what the heap spray is doing is it's allocating tons and tons of JavaScript strings full of your shellcode to completely cover the Internet Explorer heap with your shellcode. And so after this heap spray runs, you can be certain that your shellcode is located at a particular address. So once you gain control of EIP, if you put it, the bad.ani file that you're using to demonstrate control of EIP into this heap spray HTML file, and you point EIP at the address 0C0C0C 0C, 0C. At that address will be some calculator shellcode, because the whole point of a heap spray is just to make sure you get shellcode at a known address. And so that heap spray is just allocating a ton of JavaScript strings with calculator shellcode, and then eventually this address is on the heap, so we know that this address is also going to point to calculator shellcode. Okay, so once you can gain control of EIP via finding a crash in the animated cursor files, put it into the heapspray.html, set the EIP equal to 0C, 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 and you should get your calculator. All right, so that's going to be our next lab. So you guys go ahead and try to fire up the anti-fuzzer to get it going. Now, if I recall correctly, it might already be in sort of like a crashy state. Yeah, this permission denied fuzzy.ani. So I think I actually sent you guys the VM when I took a snapshot when I had already like crashed Internet Explorer. Sometimes when you crash iExplore by browsing into the wrong directory, it'll cause like a lockup like this because there's like handles open and so forth. So you might have to restart the VM if you start getting this error, and then try again. So let me see if that fixes it for me.
So if you're really mean, you can put this on someone's desktop.
Yeah, right. I mean, they'd be totally host. I guess you would have to like boot into, like recovery mode and go and delete it. Also, if you have like any Internet Explorers open or anything like that, it might not let you start the fuzzer because it's going to be trying to render those ANI files that you're writing over during the fuzzing process. So reboot, just open command.exe. Give it a go. So we can see it's like, drawing this dumb cursor each time as it's fuzzing through stuff. So yeah. So Wilbur, the password should be in that email I originally sent you guys about where the VMs were located. I believe it was something like mega vulnerable with the E and the mega of 3 or something like that. Maybe Zeno and Veronica, you guys can confirm that because I think you guys downloaded the virtual machine. You should let it get like 15 crashes, I believe. So the two phases of this lab, guys, are going to be to use the heapspray.html file to turn your ANI file into a weaponized exploit against Internet Explorer. And then once you have that working, I want you to try to exploit it without using the heap spray, so embedding the shellcode in the ANI file itself. And so that way, if you were to just browse to a directory or a file share containing that ANI file, you would get exploited. Normally, if you did that, it wouldn't work because it wouldn't launch the Internet Explorer HTML renderer and get you your heap spray. But this way, like you said, if you just put it on someone's desktop, then blam, all kinds of stuff would pop up on them. Okay, let me look at these and see if we've gotten all the ones that we want. Notice that I'm not clicking through the directory to get to my crash log file and doing it all from the command line. I use V2. Okay, you guys, after you have like 9 or 10 crashes, you have everything that you need. Yeah, after you've gotten 10 crashes, after you've done 224 iterations, you're good to go. And I want you to step through there, try to figure out what the vulnerability, which crashes are vulnerable, which ones aren't. Some of these other ones actually might be vulnerable, and I just don't know it. Some of them look vulnerable, I just didn't really waste time on them. I just went to the one that looked like absolutely the most exploitable to me. We can have a race to see who gets calc.exe popping up in Internet Explorer first. So remember the steps that you went through to analyze the CDF crashes for exploitability, and the steps you went through from turning one of those crashes into an exploit. And that's what you should be doing here. After a while, I'll obviously start working the process myself to help other people, but I want to see how far you guys can get with the training you've already had today with exploiting the crappy document reader. And like I said, since I just sort of invented this lab for the last class, like on the last night, I don't have slides for this. So can't really cheat by looking for it in the slides. Oh, so yeah, I should show you guys this. So once you get a crash, to look at it best, you should first of all just like recreate it. You can type iexplore.exe. And you need to do the absolute path to the HTML file. So for instance, okay, fuzzy.ani, this is hard-coded into the HTML file, this path, fuzzy.ani. So I need to replace this fuzzy.ani file in the c:/fuzzy directory with the ANI file that generated the crash. So for instance, if I want to look at crash 1, I would copy crash docs crash1.ani to fuzzy.ani. Yes. Then I would do iexplore.exe, and then the absolute path. This has to be the absolute path, guys. You can't just type whatever HTML for whatever reason. So iexplore.exe c:/fuzzy/fuzzy.ani.html. And this should crash when I press enter, presumably. Oops. Oh yeah, actually, what might happen actually is if you just do it without the debugger, it might generate an exception, but not actually crash, because Internet Explorer is pretty good about catching its own exceptions and then recovering from them using if its exception chain is uncorrupted. But if I were to do it in WinDebug and actually run it, you can see that I do get the exception here. It's just that when I run it on the command line, Internet Explorer's exception handlers are actually somehow dealing with this and fixing it and allowing the process to continue. So you can see this first one crashed, user32 read icon guts. What do you guys think about this one? This one look exploitable? First crash? Probably not. I mean, just right away, without even looking at anything else, we have a pointer dereference, and it's not even to a full 32-bit register, just to like a 1-byte value, so probably not interesting. And we could even do like a U EIP to look at what else is around there. So we got the line we're crashing on. Then, all right, it's moving that byte somewhere else. Then let's see, where else is, so EDI now points to our byte. So, yeah, nothing looks too good there. Not too interested in this crash.
Corey, can you make the text bigger in Notepad?
Yeah, just about to do that. So out of curiosity, for the vulnerable crash, looking at these crashes, which crash did you guys think is the vulnerable one, or one of the vulnerable ones? You got 5? 5 and 7?
Or 5, yeah, 5.
Okay, so 5.
Yeah, that's one.
Got a lot of people saying 5. Okay, so why did you guys pick out 5?
Because of that EIP.
EIP is jacked. All right, so that's usually a good sign. Do we have any exception handlers change? Let's see that. 5. So in mine, it looks like the exception handler still looks legitimate. This one right here, maybe it's one you're talking about, actually crash 6. Remember the number is at the end. So the exception handler is screwed up here, so that's a good sign. This one crashed in a rep move SD though, so okay, interesting. Any other people pick out a different crash besides 5 and 6?
9.
7, Dave? Okay, why did you pick 7, Dave? What were the things that kind of tipped you off this would be a good one? Yep. Yep. Now, were you able to, so one thing you should look for, obviously, when you're looking at these crashes is, all right, reproduce. Do you control the data that's the source of the mem copy? That's a question you should be trying to answer. Okay, we had someone suggested 9 too, I believe.
Yep.
Or was it actually, so this is the one?
I like 5.
Yes.
So with 5, you can get the. I was able to get the upper 4 bytes of EIP.
Okay.
I mean, yeah, you know, the upper half of it.
Okay.
So,
So you could still make that work with the heap spray, maybe.
that's just the first attempt, maybe.
Because maybe with the heap spray, shell code should probably still exist at address like 0C, 0C, 00000, just as that heap spray is putting your shell code everywhere, basically. So maybe you were suggesting 9 down here? Or 10, rather?
Oh no, I got you go with all the EIP.
But then I talked myself out of it.
Okay.
I confused the numbers.
So one thing that I don't like about 10 that I would see about this is that
ESI. You don't control
writing
ESI,
to the
right?
heap, okay, the heap stuff is kind of gnarly. Like I'm pretty sure you can actually exploit this. It's just I haven't talked much about how you actually exploit heap overflows. So, and I know in general that stack overflows are easier to exploit than heap overflows. So if I have a stack overflow, then I'd probably just go for that one.
5 gives you complete EIP.
5 gives you complete EIP control.
Mm-hmm.
So this one right here.
Yep.
All right.
Offset C0 on the file.
Let's see it with some calculators popping up. 5 isn't the only one though, guys. There are other crashes in here also can be turned into exploits. So don't just abandon ship and start switching on to 5. Like actually, I think when I did this with the other class, I believed I used 7, but I'm not 100% on that. But you know, 5 looks pretty good and 6 looks pretty good too. Just 6 looks good for the points that, you know, Veronica pointed out. The exception handler is all jacked up. And, you know, it's causing an exception in move SD, so that's, you know, a good sign too. The only question you have to answer is, okay, do I control the source operand? Is this data that I control? This 30B00 and all this jazz? Do I control the data that's overriding the exception handler?
Now, when you picked this vulnerability, you picked a specific one. You picked it for a specific reason, or were there a couple?
I mean, there was a ton I can choose from, obviously, in like an unpatched XP machine, but this one just sounded pretty cool.
Well, I was just curious, like, there's a particular vulnerability here that you were targeting that drew your attention to this.
But I didn't really know what it was. All I knew was that the bug report said, I mean, I could have read more into it, but I didn't want to, just to kind of challenge myself.
Sure.
And all it said was, you know, buffer overflow possible and Windows XP rendering of animated icons. And so I said, okay, first thing I do is let's go download an animated icon. How do I make Internet Explorer render an animated icon? And then just start buzzing that animated icon. That was literally the first animated icon I downloaded.
Good choice.
Yeah. I think I even just did a search in Windows, the unpatched VM for, you know, star.ani. And I was like the first one to come up or something.
Corey, how long the heat spray usually takes?
Yeah. 15, 20 seconds. Probably more like actually 10 or 15 seconds. Like if you just open up. Yeah, I mean, you could even test it out by like moving the original one in there, like original.ani, fuzzy.ani. And then doing an iExplore on just the heapspray.html. You can see that one only took like 5 seconds.
Okay, thank you, because mine was taking too long.
And you can actually verify that shellcode is actually there by doing like breaking, then U, 0C, 0C. And these other zeros, these bytes you see, these are effectively no ops that it's doing. And the reason why it uses this is because this heap spray is interesting because you know after this heap spray occurs that at address 0C, 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 0C is a knob sled and then your shellcode. Like if I kept doing unassembles, eventually I would see like standard calc.exe shellcode. But also the no ops you're using are represented by 0C, 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 0C. So if there are any function pointers on the heap when you do this, you know, it's kind of like a super easy broadsword way kind of to exploit things. If you know that you're overriding some function pointer on the heap, do a heap spray, it overrides the function pointer 0C, 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 and hey, that actually points at your shellcode too. That's kind of why they chose that magic value. It's both a no-op, a pointer to you, and a pointer to your shellcode.
So with 5, it was trivial to get the calculator up. Right?
Okay. So you can try a couple of the other crashes, or you can try, another thing you should try to do is embed the shellcode into the .ani file, so that way you don't need the heap spray to get the calculator to run. Because right now you could only exploit someone if they're visiting your website, you know, and there was like HTML rendering happening. But say you want your exploit to work if someone's just browsing to your transfer folder or something like that. That way you can just dump the shellcode. Everything, it's self-contained in the ANI file, and if they browse there, bam, they get calculators appear. And that'll be a little bit more difficult. Heap spraying makes everything, you know, easier.
Yeah.
It's also another way that ASLR is defeated in the wild exploits, just because even in the presence of ASLR, you know that if you allocate your shellcode a bazillion times on the heap, that 0C, 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 0C is still going to point at your shellcode. Or a ROP payload, or something like that. For you guys that did this, did you do a pop-pop return that it jumped to 0C, 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 or did you just
No,
point?
I just put in 0C, 0C.
Yeah.
And number 5?
Oh, you're just,
Yeah.
you're putting that in the...
So with this one, yeah, I should have clarified this. With XP-SP0, it didn't have this safe software dep and everything, so it doesn't care where you point the exception handler at it originally, it will totally accept it. So you don't have to do like a pop-pop return.
Yeah, maybe, yeah, I think that... I'm having it jump to other parts of the code,
Yeah.
and they're okay, jump.
And it's just because that was so widely abused that Microsoft decided to, you know, make it, you know, 2 steps harder to abuse their exception handlers for whatever reason. I think it was really the code red worm that prompted them to sort of make their exception handlers a little bit more hardened, even though it doesn't really matter, since you just have to do like another extra step, just since the code red exploit was using these exception handlers to be really reliable, basically. For those of you that are, you know, feeling pretty comfortable with this material, I challenge you to like go and find some more bugs in the old unpatched XP virtual machine. Just because it's, you know, kind of good practice and it's fun. Like I think, for instance, their true type font rendering and parsing, so you got TTF files contain vulnerabilities at this point, so you can try to fuzz those. I mean, there's a ton in this virtual machine for you to try to fuzz out.
Okay, Corey, so I don't know if you said anything, but I had my headset off while we were talking about stuff. So the one thing which I'm not clear on is, so I get that, you know, you want to, whenever you control the EIP, you're going to point it at the 0C, 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 then you're going to hit a NOP sled. what I'm not getting is how does your calc shell code get to the end of that NOP sled?
So the calc shellcode is, I mean, the heap spray code is designed to like put 0c, 0c, 0c like a bazillion times, and then a calc.
So to be clear,
like
built into
shellcode.
all of that obfuscated JavaScript inside the heap spray is already encoded the bytes for a calc shellcode. It's not that we're controlling the calc and putting it somewhere.
Yeah, exactly.
Okay, just wanted to make sure on that. Thanks.
Yep. Yeah, and obviously, I actually just got that heap spray script. There was like an automatic heap spray generation applet or whatever, and it tries to like obfuscate the JavaScript somewhat, so it's not quite so obvious what's going on. And that's probably why the calculator is not very obviously appearing in the JavaScript. Okay, so for anyone who wants to follow along, I'll try to see what I can do based off of the number 5 crash. That you guys seem to like that one a lot. Dave, how's it going with you? So first of all, I'll copy crash docs, crash 5.ani to fuzzy.ani. So that's the one that the HTML file is trying to use. And I'll go ahead and just run it in WinDbg to see what happens, see what I can see. Okay, and I get that EIP equals 002000000. So I'm like, is that some attacker controlled data? Well, the stack is totally screwed up, so I can't really tell. So you know what? I'm going to go ahead and just go in shooting blind and see if this value even appears. Is this attacker controlled data? And one sort of like rough way to try to figure that out is to see if this value appears in the ANI file, right? Maybe it's something the ANI file is actually writing an exception.
Okay.
Yeah, I'll have to close that, Okay, so let's see what we can see. Let's open up that thing in HXD. Okay, let's try to search for that sequence of bytes. What was it? 00200000. So presumably these would appear backwards. 00002000. Little Indian, right? Okay, so right there. So what I'm going to do is, I suspect there are other instances of this value, so I'm just going to replace each instance with like a placeholder value and see which one ends up being EIP. If this is even the thing that's overriding EIP, it may or may not be. So I'll just say 1. Okay, and there's 1. Now here's another. And another. Okay, so it looks like there was like 6 of them. So based on the results of what EIP is after I rerun this, we should know which of these is overriding EIP, if any of them. Okay, so the first one, all right. So if I come back here and replace this with the address of the heat spray address, and making sure, yeah, heatspray.html is already programmed to use fuzzy.ani as well. So if I run it with the heatspray.html, it's going to put shellcode at that address, 0c, 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 and we should have calculated something. All right. Bill, could we get the Windows updates on the display machine to go away? Okay, and for those of you that wanted to use like a different crash, let's see, we have some people using, was it Crash 7?
Yeah, try.
Okay, so you know, I don't think I've done this one, so I'll just go ahead and give it a stab. So I'm going to try to reproduce this for Crash 7 as well. And okay, so I put I copied Crash 7 to fuzzy.ani, and I'm just going to run Internet Explorer against it and see what the crash looks like. Okay, so I'm dying in a rep move SD. That's good always. And all right. Once again, I want to set a breakpoint before the mem copy is called, so I can analyze those arguments to the mem copy. So it looks like my return address is 77E74467F. So if I look at if I unassemble backwards from that address, I should see the call to the mem copy, or read file pointer copy, I guess, is actually crashing there. So what I'll do is I'll set a breakpoint here and try to see like what kind of parameters are passed to this function. I really don't even know what it does, but maybe we can sort of discern what it does by analyzing the parameters that are passed to it. I'll do a dot restart. Set a breakpoint on that address. Let it go. Okay, so what do I see here? It seems to be see what's at these parameters. 13, B6, F0. Not really sure. Might be like this destination operand. All right, some weird parameter stuff. I can see if either of these appear in the file. Maybe that will tell me something. So I'll search for this first one, the first parameter that was pushed on. All right, so it doesn't look like the first string of data is appearing. But I suspect that's like a destination operand, so let's search for the other stuff that was pushed on. So 521A DD 7734. 521A DD 7734. So this crash, man, I don't know. It's not looking too good. Not really sure if we control the source operand. Let me see if I can analyze a little bit further, though. We're going to hit this one a lot, unfortunately. This particular breakpoint. So I'm going to try to look based on where the ESI register is pointing to see what the source operand was for the actual MIM copy. So this is just right here where ESI is pointing. So DB4A, 3A6. Okay, so it was crashing because nothing exists there. Maybe if we go a little bit back, we can see what was supposed to be there. Say 0. So, looks like we don't really control the source operand that's used in the MIM copy. So I'm not real excited about that crash. It might be exploitable if we screw around with it some more, but yeah, I don't know. Which one was that I just looked at? Was that crash 6? 7? So let's see, what else can this crash 7 tell me? So on crash 7, the exception handler is intact as well. So that's kind of like another strike against it. So let's look at crash 6 instead. So with crash 6, let's see what we're about to get into. Exception handler is blown up. That's a good sign. Crashing in rep move SD. That's a good sign. Okay, cool. Let's run a windy bug, see what we see. Exception handler is all blown up. Let's see what the exception handler is getting overridden with this stuff. 00303B00. So let's see if these bytes appear in our file. Okay, that looks promising. So I'll replace these with placeholder values. Got it again, unfortunately. Let's try again. Maybe this time I'll just let it go and see if. Okay, so that was the exception handler overrunning 44444. So if I come back to where that was, again. going to see that Internet Explorer is totally freaking out because we're crashing it with this animated cursor rendering. So I'll change this to 0C. Dang it. 0C, 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 0C. Run it in my heap spray framework. If we try it even without, see what happens when we try without the window debug.
I don't think you've shouted Papa Legba at all throughout this class, so give me one good one with emphasis.
Yes, you do. You want more.
If you run it without the debugger, that's what happens basically.
Oh, the heap spray one?
Yeah. You know I would, but my enthusiasm for Papa Legba is a little bit on the down low right now with my condo, you know, about to go up in flames. So if my condo is still there when I get back, I'll let loose. Or if I see the flames raging towards me, I'll try to summon his dark patient voodoo, save my condo, because then I really will need Papa Legba to hear my call, put out the fire. So for those of you that got the calculator to pop up, class has pretty much been completed. Hopefully I've demonstrated to you that you can develop Windows exploits, bypass mitigations, and use these methods to find vulnerabilities on your own and develop exploits for them. Hope that you're all convinced of that at this point. I just encourage you to be responsible with your newfound powers. Okay? Remember, don't go to my manager and say, Corey made me do it.